Welcome to ISC Class 12 Maths Tutorial. The topic is logarithmic differentiation. Before we start, आइए आपको एक शायर की दो लाइन सुनाता हूँ. शायर कहता है, रिश्ते बने हुए हैं सभी के साथ, रिश्ते बने हुए हैं सभी के साथ, वाबस्तगी नहीं है किसी के साथ. वाबस्तगी जुड़ाव, लगाव, साथ, वफादारी, अटैचमेंट. वाबस्तगी नहीं है किसी के साथ. टूटा है एक सितारा भी आसमान से, टूटा है एक सितारा भी आसमान से, फिर बेवफाई की है किसी ने किसी के साथ, फिर बेवफाई की है किसी ने किसी के साथ. थैंक यू. The first question is, if y is equal to e raised to the power x minus y, show that dy upon dx is equal to y upon 1 plus y. This is the question. If y is equal to e raised to the power x minus y, show that dy upon dx is equal to y upon 1 plus y. This is the question. What is given? Y is equal to e raised to the power x minus y. Y is equal to e raised to the power x minus y. This is given. We take log on both the sides. Why are we taking log? This I have explained in detail in my previous lesson. So we are taking log. Taking log on both sides. Taking log on both sides. We get log y is equal to log y is equal to log e raised to the power x minus y. I have simply written log on both the sides. Log y, log e raised to the power x minus y. Now, here we'll apply the formula that we have learnt in class 9. Log m raised to the power n is equal to n log m. Alright, so this we can write down. Log y is equal to log y is equal to x minus y log e. formula we have used. Log m raised to the power n is equal to n log m. Log m raised to the power n comes out n log m. Log m, here m is e, m raised to the power n is x minus y. So n log m means e. Alright. Now after this, base is e, so log e to the base e is 1. We can write down simply log y is equal to x minus y. Log y is equal to log y is equal to x minus y. Reason, log e to the base e is 1, so that you can write down log e to the base e, since, you also can write down since log e to the base e is equal to 1. Fine. Alright. Now we differentiate both sides with respect to x. So we write differentiating both sides with respect to x. Differentiating both sides with respect to x, with respect to x, we get what do we get? ddx of log y, ddx of log y is equal to ddx of x minus y. ddx, I have written both the sides, ddx. Alright, Now the function is in y and we are going to differentiate with respect to x, which we cannot. So we write d dy of log y into dy upon dx, and d dy of log y gives you 1 upon y, because d dx of log x is 1 upon x. Alright, so dt, I am writing directly d dy of log y into dy upon dx. So d dy of log y gives you 1 upon y. 1 upon y dy upon dx is equal to d dx of x is 1 minus dy upon dx. Minus dy upon dx. Dy upon dx here, dy upon dx here, we bring together. I'll write the transpose. You can write down. So if we bring this dy by dx from right hand side to the left hand side, and dy by dx is common, so we can write on 1 upon y plus 1. 1 upon y plus 1 dy upon dx. Dy by dx is common, right? Is equal to 1. Fine. This we can write down. One plus y upon y. So 1 plus y upon y into dy upon dx is equal to 1. Alright, now this y will go up, 1 plus y will come down. So therefore dy upon dx. Therefore dy upon dx. Y upon 1 plus y. Alright? Y upon 1 plus y is the answer. Y upon 1 plus y. And this was the question. The question was dy upon dx is equal to y upon 1 plus y. So dy upon dx is equal to y upon 1 plus y, we showed. This is the result. This is the result. Proved. Or QED. Q E hence proved. Showed which was to be shown. Clear? Okay. Now, next question. Question number 2. Next question is, if x raised to the power m, y raised to the power n, if x raised to the power m, if x raised to the power m into y raised to the power n, into y raised to the power n is equal to x plus y m plus n. Prove that dy upon dx is equal to y upon x. To prove that dy upon dx is equal to y upon x. This we have to show. dy upon dx is equal to y upon x. An important question. IEEE, ISC, CET Karnataka, it has been asked. Now, given x raised to the power m into y raised to the power n is equal to x plus y whole raised to the power m plus n. This is given. X raised to the power m into y raised to the power n is equal to x plus y whole raised to the power m plus n. Alright. M plus n. Now we take log of both the sides. So write down, taking logarithm on both sides we get. Taking logarithm on both sides we get. Taking logarithm on both sides we get. You write down full. On both sides we get. Okay. Log and log. First I am writing simply log on both the sides, and then we will apply the formula which we have learned in class, in previous classes, in class 9. So log can write down log x raised to the power n into y raised to the power n is equal to log x plus y whole raised to the power m plus n. X plus y whole raised to the power m plus n. Now let's apply the formula. Please try to understand. First, this total we are taking as m. X raised to the power m we are taking as m, or you can see e. Log a into b is equal to log a plus log b. Log m into n is log m plus log n. And then you have in product, right? Log this total is a. This total you can consider as a, and this total you can consider as b, or mn. So log m, I'm not saying m because already we have m, so that's why I'm saying log A. Suppose this is capital A, this full. This is capital A and this is capital B. So log AB, log A into B is equal to log A plus log B. Alright, so we are going to write down that log product, no? So we are going to write down log so we write log x raised to the power n log x raised to the power n plus log y raised to the power n is equal to log m whole raised to the power n. Alright, log x whole raised to the power y, log a whole raised to the power b. Alright, so this will come out m plus n log x plus y. M plus n m plus n log x plus y. Alright, formulas you should write down here, the formulas that you used. You used basic formula log mn is equal to log m plus log n. Correct? This formula we have learnt in our classes. Alright. And 1 log m raised to the power n is equal to n log m. Second formula, log m raised to the power n is equal to n log m. Alright. These are the two formulas that we have used. Again, this formula we are going to use here. So next step will be n log x, and this will be n log y. Alright. I didn't do in one step. We could have done that. We could have written that also, m log x, but I didn't do so that you understand. Clear? So next step we write m log x. M log x plus n log y is equal to m plus n log x plus y. Same formula, log m raised to power n is equal to n log m. This index come outside, right? Power. So m log x, this formula we are using. Clear? Okay, now we differentiate. So on differentiating both sides with respect to x, we get differentiating both sides with respect to x, we get now I'm writing directly one step. Alright. I am writing like this. Just 1 minute. So m and ddx of log x, and ddx of log x is 1 upon x. Alright, so m into 1 upon x. M into 1 upon x. Alright, plus n into dy of log y into dy upon dx. That means 1 upon y into dy upon dx. Got it? One upon y into dy upon dx is equal to m plus n as it is. ddx of log x, if we suppose this total as x, chain rule, so ddx of log x is 1 upon x. 1 upon x. X means here in our case x plus y. And because it is not x, so once again we differentiate it. When we differentiate x, that gives you 1. And when we differentiate y, we get dy upon dx. Right? Chain rule. Okay. Now we have to bring dy upon dx on one side. We'll get the answer in 2-3 steps. We'll get, either you bring, first you multiply this to 1, so m plus n upon x plus y into 1 means same, and then this upon this into dy upon dx. Now either you bring this dy upon dx to the left hand side, or you transpose this from left to the right hand side. Either way it is okay. Alright, what do you want? Let us write down dy by dx this side. So n upon y, and here it is minus m plus n upon x plus y and dy upon dx. I am taking common dy upon dx, if you understand, into dy upon dx. Into dy upon dx. Is equal to, now this into 1 is same, m plus n. M plus n and whole divided by x plus y. And this comes this side, minus m upon x. Alright, now LCM we take and we subtract, so LCM will be y and x plus y. Here we get into dy upon dx. Is equal to, now here we get nx minus ny, alright? Nx minus ny minus my minus ny. Minus ny, alright, into dy upon dx. Into dy upon dx. Is equal to, here mx plus nx minus mx minus my and whole divided by x plus y. Alright. Now this x plus y x plus y cancel. X plus y and x plus y cancel. Here ny nx plus ny, this is plus, nx plus ny, this is plus. Alright, so this ny cancel this minus ny, this minus mx plus mx and minus mx. Alright, so what is the remaining? That let us write down. Remaining term. What remains is nx minus my. Alright, nx minus my whole divided by y into dy upon dx. Is equal to nx minus my upon x. Alright. Now nx minus my, this side also, this nx minus my, nx minus my cancel. Alright. We get 1 here, so right, we are getting 1 here, 1, and here also we are getting 1. 1 upon y dy upon dx, 1 over y dy upon dx is equal to 1 upon x. Therefore, dy upon dx is equal to therefore dy upon dx is equal to y upon x. And this we have to show. Find QED. QED. Or you write down hence proved. Clear? This is the question. Dy upon dx is equal to y upon x. Yeah. We have to show dy upon dx is equal to y upon x. I hope everything is very, very clear and you enjoyed the lesson. Thanks for watching the lesson. Bye for now.